Okay, this lesson on scientific notation, lesson 8.4. So just a little review of what scientific notation actually looks like. And this you'll probably remember back from Math 87 or even pre-algebra. That every scientific notation uses the same format. It's a number between 1 and 10 times 10 to an exponent. Now, this exponent, a lot of people mistakenly believe that it's the number of zeros in a number or something like that, and it's not. That exponent basically tells you the number of spaces that you moved the decimal or the decimal moved whenever you made it scientific notation or went back to standard form, which, by the way, standard form is just the regular numbers that we deal with all the time. So whenever we deal with scientific notation, has to be a number between 1 and 10. Can be 1, cannot be 10. So it has to be somewhere in that mix, times 10 because it is a power of 10 to an exponent, and again, that exponent tells you how many spaces things moved. So let's look at some examples here. All right, let's look at example 1. Example 1 says, get that out of the way. Example 1 says 42,590,000, write it in scientific notation. So if, again, we have this number between 1 and 10, and obviously 42 million plus is not between 1 and 10, we have to make it a number between 1 and 10. So that decimal can only go one spot, and that would be right there, in between the 4 and the 2. That has to be in between 4 and the 2, because if it was like behind it, say like 42.5, in front of it, 0.42, none of those fall into this category between 1 and 10. So there's only one option for that to go, which is 4 point. Now you got to keep all the rest of it there. So 4.259 times 10 to an exponent. And that exponent is going to be, again, how many spaces you moved. So whole numbers have decimals at the end. 1, 2, 3, 4, 5, 6, 7. So that's the reason why it's times 10 to the 7th. B is the other way. You start off with a very small decimal. Again, has to be a number between 1 and 10. So this is the only spot for that to go. 5.74, that's your number between 1 and 10, times 10 to an exponent. You moved it 1, 2, 3, 4, 5. But this one is a negative exponent. Now there is a difference. Well, there I moved it 7 times and it was positive. Here I moved it 5 times, it was negative. Has nothing to do with how many times you moved it. It has to do with what kind of number it is. Here's how I tell you to remember it. If it, in standard form, is a number bigger than 1, it will have a positive exponent. If in standard form it is a number less than 1, it's going to be a negative exponent. Okay? So a lot of people trying to remember it, oh, if I move it to the left, it's this. If I move it to the right, it's this. That's not really true, and it can actually cause some confusion whenever you go back this way, writing numbers in standard form. Oh, well, I moved it to the right, but this time isn't. So don't remember anything about moving it left or right, and that's what kind of number it is. Remember it if it is a number greater than 1, it's positive. Positives are greater than 1. If it's a number less than 1, it's a negative. Most numbers less than 1 are negative. All right. Writing numbers in standard form. That's just a regular plain old number. So they give you one in scientific notation. This exponent right there tells you you're going to have to move the decimal 6 times. The fact that it's positive tells you you should end up with a number bigger than 1, which means we're going to have to move it to the right. 1, 2, 3, 4, 5, 6. 2,007,500. B, 1.685 times 10 to the negative 4th. This, yes, we're moving a decimal 4 times, and because it's negative, that should tell you that you should end up with a number less than 1, which means I'm going to have to move it to the left to make it a very teeny tiny decimal. Okay? So, practice at the bottom. Writing that number in scientific notation has to be a number between 1 and 10, so the decimal has to go here. 5.39 times 10, this part's always the same, times 10 to the, I moved it 3, 4, 5 times, and it's a positive 5 because my standard form number is bigger than 1. Second part, then write the number 4.5 times 10 to the negative fourth in standard form. So if it's 4.5 times 10 to the negative fourth, yes, I move it 4 times, but because it's negative, I have to move it to the left. 1, 2, 3, 4. 1, 2, 3 zeros, 4, 5. And that would be my answer. Okay, top of the next page. Ordering numbers in scientific notation. It's easy to order things from least to greatest. Just tell which one's the smallest, put the next one in order, the next one in order. But it's not as easy to see which one's bigger than another one if they're not in the same form. So my advice to you is either to switch them all to standard form or switch them all to scientific notation. If it were me, 2 of them are already in standard form, so I would probably just switch this one. 7.8 times 10 to the 8th. So that means I would have to move this decimal. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to fill that in with 7 zeros. 7, 8, 1, maybe. 1, 2, 3, 4, 5, 6, 7. The number 780 million. 780 million. So if I do least to greatest, least, next biggest, biggest. Now, even though I just found that that was 780 million, it does want the original numbers. So don't write down 780 million. Write down 7.8 times 10 to the 8th. Okay, moving on. Evaluating the expression. You're going to be multiplying, and actually doing some other things too, but multiplying numbers that are in scientific notation. So if you look at A, I kind of think of this like, what if I had 5x times 2x? Right? I would multiply my numbers in the front and give it a 10. And because I'm multiplying these two like bases, I would add the exponents. That I'm sure you already know. This part, however, is no different. I'm going to multiply my numbers in the front. 8.5 times 1.7, that's where my 14.45 comes in. And then because I'm multiplying like bases, I need to add the exponents. That's where the 10 to the 8th come in. Now, this is correct. The only problem is that it is not in proper scientific notation. So if I take that 14.45, just that part alone, and write that in scientific notation, it's going to be 1.445 times 10 to the, well, I would only have to move it 1 time. It started off as a number bigger than 1, so it's a positive 1. Now, if I bring this 10 to the 8th and tack it right onto the end, times 10 to the 8th, this, proper scientific notation, times 10 to the 1st times 10 to the 8th, like bases, so I add the exponents, 10 to the 9th. And that's the reason why that's our answer with that. Next one. 1.5 squared is 2.25. 10 to the negative 3 squared, I'm raising a power to a power, so just like I did in 8.3 and 8.2 and 8.1. Raise a power to a power, you multiply. So that's the reason why that's 10 to the 6th. This is proper scientific notation, so I'm done. Next one, instead of multiplying them, this is a division of scientific notation. So I'm going to actually divide my numbers in the front. 1.2 divided by 1.6, that's where the 0.75 comes from. And then if I'm dividing like bases, I have to subtract the exponents. So a lot of you may think that this is a 1, but it's not. It's a 4 minus a minus 3. So that's where the plus plus comes in. 4 plus 3 is 7. Again, this is fine, but it's not proper scientific notation. So I have to change this part, 0.75, into this part. It's a negative 1 because it started off less than 1. Multiplying like bases here whenever I put that 10 to the 7th on the end. So when I multiply like bases, I have to add the exponents. Final answer, 7.5 times 10 to the 6th. Okay. With that being said, we're going to go down here to the guided practice. Number 2, I think you'll probably be okay. So either change them all to scientific notation or all to standard form, whichever one you think is easier, and go that way. Number 3. Number 3, and just for calculation's sake, I'm going to go ahead and put a calculator up here. 1.3 squared. 1.3 squared. So 1.3 times 1.3 gives me 1.69 times 10 to the, raise the power to a power, I multiply 10 to the negative 10th. And that is proper scientific notation, so I leave it just like that. Next one, I'm dividing 4.5, probably shouldn't even need a calculator for this. 4.5 divided by 1.5 is 3 times 10 to the, I'm dividing like basis so I can subtract the exponents. 5 minus a minus 2, 7. And that is proper scientific notation so that I can leave. This one, multiply my numbers. 1.1 times 4.2 gives me 4.62 times 10 to the, multiplying like basis, so I add the exponents. 4.62 times 10 to the 9th. And that is the end of the lesson. So hopefully that came back to you rather quickly, and the exponent properties seem to make sense with that. If not, make sure you take notes on your questions and ask me tomorrow in class, and we'll get it taken care of. Good luck.